Welcome back, and this is another section where we'll learn about iterators and generators, and we'll learn the difference between iteration and generation in Python and how we can construct our own generators with the yield statement. Generators allow us to generate as we go along instead of holding everything in memory. So that's why generators are much more efficient. Now, we've touched on this topic in the past when we were actually talking about the range function, and with difference between the x range was being a generator while range was not, right. So let's explore a little deep. We've learned how to create functions with the def and the return statement. Generators allow us to write a function that can send back a value, then later resume to pick it up where it led off. So the type of function is a generator in Python, allowing us to generate a sequence of values over time. The main difference in syntax will be use of the yield statement. So we'll see that in an example, but before we get to that example, I just want to explain that in most aspects, a generator function will appear very similar to any other function, but the main difference will be that when a generator is compiled, they become an object that support an iteration protocol. That means when they are called in your code, you don't actually have to return a value and then exit, but the generator functions will automatically suspend and resume their execution and state around the last piece of value or last point of value generation. This is the reason, this is a basic functionality of what a generator does. But the main advantage here is that instead of having to compute an entire series of values up front and keep it in memory, generator functions can be suspended. Now, this feature is also called as state suspension. I'll share some reading materials after this, but to start a better understanding of generators, let's go ahead and see how we can create some. And I'm going to open my notebook here, and let's get started with some examples. So to start getting a better understanding of generators, let's go ahead and see how we can create some. And this is how we create a function, right? So, and I'm going to create a function, and then it says n. So this is a generator function for the cube of numbers, so the power of 3. This is how we do it for all numbers in range. I'm using the range function, right, and which is a built-in function, and it yield a number 3. This is a not similar to a return statement, but it does not keep anything in memory, while a return statement keeps in the memory. This runs through the iteration, but return is a statement that returns a value after the iteration process is done. So I'll show you this is in the example. And if I do an execution of this particular function, and then I print the value of x, and it prints me the cubes of all the numbers from 0 to 10. So now we have a generator. We don't have to keep track of every single cube we created, right? Generators are best for calculating large set of results, particularly in calculations that involve loops themselves. So it's very important that we use generators and know where to use generators. Generators are used in cases where we don't want to allocate the memory for all the results or at the same time. So in this case, I'm not sequentially tracking them, I'm not allocating any memory, and that's when I use generators. It improves the efficiency of your program. The yield statement does not keep anything in memory, unlike the return statement. And let's create another example of a generator which creates Fibonacci series. If you don't know what is Fibonacci series, you'll get a primer on this soon. But if you'd like to read about it, feel free to read it. Fibonacci series is nothing but it adds the previous number and prints the result. So let's see what I'm talking about. I'm going to create a decorator function, which is a generator function, and that will. So I'll use the doc string, and this is how we create a generator according to standards. Yep, and that's how we do it, and that will help users know what this function is all about. And I will assign these values. So I will begin my Fibonacci series from 1. Now for all items in my range, yield A, which is A and B, take A and B, assign the values, and then do print A plus B. So that's what a Fibonacci series is all about, right? So if I print this like this for every number in, right, then print the number. Now when I do this, when I do this, it will print the Fibonacci series. So 1 plus 1 is, it starts with 1, takes 1 and prints 1. All right, so that's how we have A and B are printed like this. A and B are printed, and now it takes B. It takes this B and then adds that B with value of A, which is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8, and so on all the way till the range 10. Right. So what if this was a normal function? How would it look like? So if I had to do a normal function, I would do something like this: give it a name, and then it would take a number as value, and then A is equal to 1, B is equal to 1, and I need to define how I want my output. So I want an output as an array, right? And I would iterate over it like this in the same way I did for a generator. Only thing is, I will do an append method which will append my output list with values it generates during the iteration, and we know lists are appendable, and then I would do A plus B, and then let's return output. So what do you think this should have? This should give you a list of Fibonacci numbers when I run this function. So let's say, and it will return a list. Notice how we can call some huge values. So if I change this value to 100, 1000, the second function will have to keep track of every single result, right? And in our case, so this we actually only care about the previous result to generate the next one, right? In this case, it has to keep a track of this, and then it should be able to iterate over every number in the range and go back and then maintain a list. Right. So next, look at some built-in functions in the next session. I hope you are clear. So see you in the next class.